133 days on the Sun. If we were to attempt such a task, we would rapidly be incinerated into an inferno of heat and radiation. The surface of the Sun, with temperatures reaching up to a staggering 5,500 degrees Celsius, is nearly impossible for any form of life as we know it to survive on. However, if we were to indulge in a hypothetical scenario where our technology advanced enough to allow such a feat, we could examine the life cycle of the Sun and its effects on our prolonged stay. Firstly, it is crucial to understand what the Sun is and how it functions. The Sun is a star, an immense celestial body consisting mainly of hydrogen and helium gases, with smaller quantities of other elements. Its energy source is nuclear fusion, the process of combining two atomic nuclei into a single, heavier nucleus. This reaction produces a massive amount of energy in the form of light and heat, which emanates from the Sun's core and radiates out through its many layers. The Sun goes through several stages in its life cycle, each with specific changes and impacts on the solar system. After about 4.6 billion years, it will evolve into a red giant, expanding up to several hundreds of times its current size and engulfing Mercury and Venus in the process. Earth would technically still exist, but it would be so far from the Sun's surface that it would be uninhabitable. Now back to our hypothetical 133-day journey on the Sun. To even consider such a feat, we would need to create a protective suit that can withstand the intense temperatures and radiation from the Sun's surface. With a temperature of 5,500 degrees Celsius, we would need to develop a suit that can withstand up to 10,000 degrees Celsius, just to be safe. It would require specialized materials, such as carbon composites and ceramics, to withstand such intense temperatures. Assuming we could survive the journey to the Sun's surface, what would we experience? The Sun's surface, or photosphere, is a bubbling mass of plasma, with solar flares and prominences continuously erupting from its surface. These bursts release tremendous amounts of energy and radiation, which can be hazardous to life as we know it. Any unprotected human would be incinerated within seconds. However, with the specialized suit, we could potentially explore the surface of the Sun, studying and recording its various phenomena. The Sun's heat and radiation would also impact the suit's technology. We would need to develop specialized sensors and instruments capable of operating under such extreme conditions. Power systems would be a challenge, considering any form of traditional batteries would not survive the journey. Solar panels would be useless that close to the Sun, so alternate power sources would be necessary. The psychological effects of the journey would also need consideration. Being cooped up in a suit for 133 days, potentially with the only view being the Sun's surface, would take a toll on any person. Astronauts who spend extended periods of time in space have reported feeling isolated, anxious, and even depressed, so it's fair to assume a mission like this would require specific mental health support. In conclusion, with our current technology, a 133-day mission to the Sun is a near impossibility. However, with rapid technological advancements, it's not entirely out of the question. The surface of the Sun is a fascinating and awe-inspiring sight, and the chance to study and explore it would provide invaluable scientific knowledge. If we can develop the protective gear and technology necessary to survive the Sun's intense conditions, there's no doubt that humanity would be eager to explore it.